Hello. Yeah, anyone respond in chat box? Hello. 564. Are you there? Hello. Five 64. 576. Can you hear me? Yeah, anyone respond in chat box? Hello. Yeah, okay, fine. I shared PPTs. The slides are visible. Okay. Now today we'll discuss the last topic in second unit, geometric distribution. Yeah, this is already covered. This is the revision class. Hello. This is the revision class. Already we learned binomial distribution and Poisson distribution. These two are for discrete case. The random variable is discrete random variable. Okay. And this is also geometric distribution also in case of discrete random variable. And once all of you see the point here, geometric distribution is similar to the binomial distribution. But instead of tossing a coin for a fixed number of times and observing for a head or heads. Here R represents the number of tosses we did until head is get. Okay, there is a difference. In binomial distribution, what we did, how many heads we get, there is a difference. Okay, or one head or two head or three heads. Small difference is there for binomial and geometric distribution. Tossing a coin continuously. Suppose after tossing a coin 5 times, the 6th time you got it head. In such case, you can take R is equals to 5. Okay. Now we'll discuss the problems on geometric distribution. And also see the definition. A discrete random variable x is said to have geometric distribution. Its probability mass function is given by probability of x equals to r. X equals to r. That is equals to p into small p into q power r minus 1, where r is equals to 1 to so on, and p is a success, q is unsuccess, that is q equals to 1 minus p. R is the number of trials required until to get a first success. To get a first success. Okay. And the mean of geometric distribution is 1 by p. Variance of geometric distribution is q by p square. Q by p square. We'll discuss that one, how to mean of geometric distribution. In general, we know that mean of geometric distribution is expectation of x. Expectation of x. Okay, here geometric distribution is in case of discrete random variable. If x is a discrete random variable, expectation of x is equals to summation x into p of x. Only we know that formula in discrete case and continuous case, how to write expectation of x and how to write expectation of x square. All of you know the formulas, right? Just I'm using the basic concept, how to find mean. The mean of geometric distribution, expectation of x is equals to summation x into p of x. Here probability function, this one p of x follows the following geometric distribution. Just now discussed geometric distribution, p of x is p into q power x minus 1 or r minus 1. Okay, we have to substitute that one in this one. Summation x equals to 1 to infinity small x into p into q power, just a minute, q power x minus 1. Here p is a constant. P is a constant because summation involving x. Now you can take p outside. See here q power x is there. We can't take q outside because q is depending on x. Summation is also involving x. That's why here we can't take q outside. P is a constant. P is not depending on x. Now you can take outside. Okay, when you're taking p outside, summation x equals to 1 to infinity x into q power x minus 1. Q power x minus 1. P into, now expand the summation. When x equals to 1, 1 into q power 1 minus 1. Q power 1 minus 1, q power 0, that is 1, the first term. Okay, when x equals to 2, when x equals to 2, 2 into q power 2 minus 1, 2. Like this one, we have to expand. And all of you observe this expansion. In first year, we discussed these expansions. Okay, we know that 1 plus x whole power minus 1, 1 plus x, 1 minus x whole power minus 1, 1 plus x whole power minus 2, 1 plus x or 1 minus x whole power minus 2 expansions, we know that. By using binomial expansions, this one can be written as 1 minus p whole power minus 2. This expansion can be written as 1 minus p whole power minus 2. Okay, we know that p plus q is 1. P plus q is 1. Q is there. 1 minus q equals to p. P power minus 2. P power minus 2. Now when you are simplifying this one, you can get 1 by p. This is the mean of geometric distribution, that is 1 by p. Is it clear? Anyone respond in chat box? Yeah, okay, fine. Now, anybody tell what is the variance formula in discrete case? Yeah, what is the variance formula in terms of expectation terms? Yeah, what is the variance formula? Expectation of x square minus expectation of x whole square. Now next we'll discuss variance of, yeah, very good, 57D. Variance formula is expectation of x square minus expectation of x whole square. Very good, mom. X whole square. All of you see that one. Variance of geometric distribution. Variance of x is equals to expectation of x square minus expectation of x whole square. Just now we did expectation of x, that is 1 by p. Here, no need to worry about this one. Already we know this value, expectation of x, we know that. First, we have to find expectation of x square. After that, substitute in this equation. Okay. Now, first we are finding expectation of x square. Expectation of x square can be written as summation x equals to 1 to infinity x square into p of x. P of x. P of x following geometric distribution. We know that geometric distribution p into q power x minus 1. But here finding variance, that is a main key point for variance. Here x square is there. X square can be written as x square minus x plus x. Change. Just we're adding and subtracting x. Adding and subtracting x. And after that, here first two terms, x square minus x, I'm considering as one term. That is the one term plus x is the one separate term. See here, x square minus x. In these two terms, I'm taking x common. When you're taking x common, we'll get x into x minus 1 plus x into p of x as it is. P of x as it is. Okay. Now separate the terms. First, I'm taking summation x into x minus 1 into p of x plus summation x into p of x. All of us see the second term, summation x equals to 1 to infinity x into p of x. That is expectation of x. Just now we discussed expectation of x. We know expectation of x value, that is 1 by p. 1 by p. Keep that one as it is. Now all of you simplify this one. First term. Okay. Here summation x equals to 2 to infinity x into x minus 1 into p of x. Okay. We know probability distribution for geometric function or geometric distribution. That is p into q power p of x. Okay. Now all of you see this one. Summation x equals to 2 to infinity x into 1 minus x p into q power x minus 1 is there. In this one, p is the constant that is not depending on x. Now you can take outside. Now you can take outside. Yeah, taking p outside, the remaining is summation x equals to 2 to infinity x into x minus 1 q power x minus 1 into expectation of x. Expectation of x. Okay. Now expand the summation. P into expand the summation. When you are expanding that summation, you get like this one. P into 2 into q plus 3 into 2 into q power 2 plus 4 into 3 into q cube plus so on and so on. Plus the last term is expectation of x. We know that expectation of x, that is 1 by p. 1 by p. And all of you see this expansion. In all these terms, the common thing is 2 into q. 2 into q. When you are taking 2 into q outside, this term can be written as p into 2 into q into 1 plus 3q plus 6q square plus 10q cube plus so on plus 1 by p. 1 by p. This one. Okay. Now this one, all of you observe carefully. This expansion can be written as 1 minus q whole power minus 3. 1 minus q whole power minus 3. Now you can simplify that one. You can get that is 2pq into p power minus 3 plus 1 by p. 1 by p. After getting expectation of x square, substitute expectation of x square and expectation of x in variance formula. The variance formula is this one. V of x equals to expectation of x square minus expectation of x whole square. Okay. All of you substitute the 2 in this one, then simplify. You can get that one, variance of geometric distribution, that is q by p square. All of us simplify that one, you can get variance of geometric distribution is q by p square. This is a very small topic. Just remember what is the geometric distribution, what is the mean and variance. Mean of geometric distribution is 1 by p. Variance of geometric distribution is q by p square. Q by p square. I hope all of you understood these two. This is just revision class. Only we completed this topic. Still, you have any doubts? I will clarify now. Otherwise, I will start problems on this one. Yeah, anyone respond? Shall I start the problem? Or you have any doubts in mean and variance? I will explain that one. Otherwise, I will start the problems on geometric distribution. Yeah, okay. Now we'll start problems on this one, geometric distribution. Now once all of you see that question, a die is tossed until 6 appears. A die is tossed until 6 appears. Find the probability that it must be at least more than 5 times. More than 5 times. Okay. Now when you are a die is thrown, the probability of getting 6 as many one. When a die is thrown, what is the probability of getting a number 6? 1 by 6. Very good. Okay. Here, see, what is the question? A die is thrown or tossed until 6 appears. P indicates, small p indicates probability of getting success. What is the success here? Getting 6. Getting 6. So probability of getting 6 is 1 by 6. Then small p is equals to 1 by 6. Small p is equals to 1 by 6. If you know small p, then easily you can find out small q. What is the small q? 1 minus p. 1 minus p. P value, you know that 1 by 6. You can get q. That is 5 by 6. That is 5 by 6. And see here, this is x. Let x be the number of times a die is tossed until 6 appears. In the question, they mention we have to find probability that it must be at least more than 5 times. More than 5 times. That means x is taking values more than 5. X is taking values more than 5. In that case, we have to find probability of x greater than 5. X greater than 5. For finding this one, we have to use this logic. We have to use that logic. Because here there is no bound that goes on. That's why we know that total probability is 1. For finding this probability, we have to use this logic. 1 minus probability of x less than or equals to 5. Easily you can get. Easily you can get. Okay. 1 minus of. Okay. This one, probability of x less than or equals to 5, that can be written as probability of x equals to 1 plus probability of x equals to 2 plus probability of x equals to 3 plus probability of x equals to 4 plus probability of x equals to 5. And here, remember the probability following geometric distribution. Okay? Distribution. We know p and q values. And also we know that geometric distribution, probability of x equals to x r into q power x minus r minus 1. Sorry, x minus 1 r minus 1. geometric distribution. Probability of x equals to r is p into q power r minus 1. By using this one, all of you find out these probabilities, then substitute in this one. Probability of x equals to 1, probability of x equals to 2, and so on. Substitute that values here. In all these terms, p is common. Now you can take outside and substitute small p and small q, then simplify. You can get the required probability is 0.41. 0.41. 0.41. Okay, all of you understood? In exam, they won't mention anything. Just the ask question like this one. We have to identify. For geometric and binomial, one small difference is there. I think all of you understood the point. And see the next question. Shall I move? The first problem is completed. Shall I move? Yeah, once all of you see the second question. Produced by a machine has 3% defective rate. What is the probability that the first defective occurs in the fifth item inspected? The same thing, just now we discussed the same model, but only small difference is there. Here, all of you see that solution. Let small p be the probability of getting a defective item or defective rate. This small p is equals to 3%. That is equals to 0.03. 0.03. Let small q equals to 1 minus small p. 1 minus small p. You can get the small q is equal to 0.97. 0.97. 0.97. And let capital X be the number of times a defective appears. A defective appears. Once all of you read that question, and you can take X value. See, what is the question? What is the probability that the fifth defective occurs? What is the probability that first defective occurs in the fifth inspected? Okay, that means the first defective is in fifth inspected. That is x equals to 5. Very good. So 570. X equals to 5. Now we have to find probability of x equals to 5. See the previous one and this one, small difference is there. Previously they're asking minimum 5, okay, more than 5. Here exactly x equals to 5. Probability of x equals to 5 is equals to, we know that is following geometric distribution. That is equals to p into q power x minus 1 or r minus 1. Okay, we know p value, q value, and x. Substitute in this one and substitute, simplify. You can get the required probability. You can get the required probability. Yeah, Asma, this is about the distribution, and this is the last topic in Unit 2. This is the last topic in Unit 2. In Unit probability distributions, random variables and probability distributions. Random variables, discrete and continuous, how to find k values. In both cases we covered, and both cases we discussed so many problems, how to find mean and variance. Mean and variance, the problems are important. How to find k and mean and variance. In external exam, definitely they will ask one question, either discrete or continuous, finding k and mean and variance. Okay, and after that we discuss probability distributions, binomial and Poisson. Binomial and Poisson are important, and this is a very small topic, geometric distribution. This is the last one in Unit 2. In Unit 2. Okay. There's many doubts in Unit 2. I will clarify now. By 3:30, we'll start the quiz. All of you log in with KMIT online, and all of you write the quiz. That's why still anybody any doubts in Unit 2, I will clarify now. Does anybody have any doubts? Yeah, Unit 2, we covered the topics, random variables, discrete and continuous. In both the cases, we discussed problems on how to find k, how to find mean, and how to find variance. And probability distributions, binomial, Poisson, and geometric distributions. These three distributions are in discrete case. In discrete case. The third unit is continuous random variables, continuous distributions. Okay. Is there anyone? If you have any doubts, I will clarify now. No doubts? But in exam, they won't mention anything. Just they will ask the question, find the probability. First thing, you have to identify that is discrete random variable or continuous. Discrete random variable, we have three types. Three distributions are there. Discrete case, binomial, Poisson, and geometric. Okay, all of you read that question carefully, and we have to understood which distribution is applicable for whatever the given question. Binomial distribution is for finite and success and failure. N is finite and that contains only two possible outcomes, success and failure. And when you come to Poisson distribution, the Poisson distribution is applicable for rare events. That means Probability value is small p value is very small. Small p value is very small or n value is very large. Remember that cases. In such case, you can apply Poisson distribution. You can apply Poisson distribution. And geometric just now we discussed. That is just like binomial, but one small difference is there. In binomial distribution, we are finding the number of heads or number of tails, but here R indicates the number of trials. Okay, as this is the unit 2 revision class is also over. Okay, and tomorrow is also quiz is there. Tomorrow we are conducting, as all of you listen carefully. As all of you listen carefully. Tomorrow we are conducting quiz on Unit 1 and Unit 2. All of you listen carefully. Tomorrow we are conducting quiz on Unit 1 and Unit 2, both the units. The quiz contains 10 questions. Quiz contains 10 questions. Okay. If you have any doubts, today all of you prepare Unit 1 and Unit 2. If you have any doubts, tomorrow first 20 minutes we'll discuss. After that, we'll start the quiz. The quiz will start 4:35 to 5:15. Tomorrow quiz contains 10 questions, not 5. Remember that point. Tomorrow quiz is important. All of you write that quiz. Okay? Once again, I'm repeating. Tomorrow we are conducting quiz on the first and second units. The quiz contains 10 questions.